Good day, everyone. Welcome to Tutors. On today's episode of Sub-Depositional Environment, we are going to talk about the Crevasse Splay. The Crevasse Splay. This is another scenario that is formed under the meandering, the main meandering depositional environment setting. So, what really forms the Crevasse Splay? Journey with me. Now, the major channel is still operating, right? For the Crevasse Splay, we have the major channel that is still operating. The major channel is still operating. Can you see? The major channel is still operating, but due to increase in discharge, due to what? Increase in what? Discharge. Maybe there is rainfall, or probably there is much load, load of sediment. Okay, due to increase in discharge, there will be a crack at the overbank. You know, the bank of the river, the edge. Okay, there will be a crack at the overbank, and due to this crack at the overbank, what happens is that what? There is a deposition that is not deposited into the floodplain. The position that's now what? Deposited into what? It forms a micro channel. So you know there are sediments inside this system, right? So those sediments will be kind of coarse, you know. So those sediments will now be deposited inside this floodplain. So this sub-depositional environment is formed in this way. It is formed when the major channel is still operating, but due to increase in the discharge, there will be a crack at the overbank, and the Crevasse Splay is deposited in a micro channel. Good. Now, you know, I'm talking about floodplain. Let me just describe what floodplain is in a fluvial system. Floodplain. What is a floodplain? Or how is floodplain forms? No, let me give you a kind of scenario. Now look at this. I said, so some heavy rainfall will cause water splash everywhere. Heavy rainfall will cause what? Water splash everywhere. So if you know when there's heavy rainfall in a particular place, you know there'll be a place where there will be stagnant water. Do you know that when the stagnant water dry, maybe it dries off, or beneath a very, very long stagnant water, what are you going to see there? What are you going to see beneath it? Something like a muddy, abi? Something muddy, something clay. You understand? Something muddy, something clay. Yes. So that is why outside, like after the bank or the river, in this other side, what you are going to have is mud. The kind of lithology that you have in this place is what? Mud deposition. And that is where we call the floodplain, where what is dominant in the floodplain of a fluvial setting is what? The mud. Okay, the mud. Now normal we have the mud here. So now this coarse grains that were in this fluvial system will now be deposited into it. Now be what? Deposited into the system. Good. So when you enter this micro channel is called the crevasse splay. The Crevasse Splay sub-depositional environment. The Crevasse Splay sub-depositional environment. Crevasse Splay sub-depositional environment. Good. Now, can you see that? The back is broken, the micro channel, the system. Now let's look at a typical, what we have here is a typical meandering river. This is a sketch of how the normal point bar, you know, the main deposition in a meandering river setting, the main thing that is being deposited, we call it the point bar. Don't forget, point bar, point bar deposit. That is what is being deposited. Okay. Now, this that's the main deposition as well. You know, for braided system, we have the braided bar deposit, but here we have point bar deposit. Now, as every fluvial setting, there is have what we call the erosive base. The erosive base, which means in this fluvial setting, you know, as river move or any agent of erosion that moves, it erodes, right? So as it erodes, it has the erosive base. Can you see? Very fluvial setting, we have it starts with the erosive base. That's the first thing in it. So after erosive base, the next thing you're going to have is the channel lag deposit. What is a channel lag deposit? A channel lag deposit is kind of deposit that is formed in the deepest part of, that's the talweg, in the deepest part of a channel. And what consists of it? The things that consist of it are gravel size deposits. You know, gravel are very, very large. So gravel size deposit. Gravel size deposit. Okay, gravel size deposit. Then later we have a trough cross-bedded sandstone. Point bar deposit more consists of sandstones and the rest. Trough cross-bedded sandstone, planar cross-bedded sandstone, ripple laminated fine sandstone. These are different facies that are presented in the point bar depositional model, which is the majorly the meandering depositional facies model. This is the meandering depositional facies model, the standard meandering depositional environment model. Okay. Then after that, on top of all of this, you're going to have the overbanks, which is the floodplain. You're going to have the floodplain on it. So the floodplain is the last setting, which is near the clayey or the muddy region, because no matter any deposit that is there, due to meandering river always moving, always migrating laterally. As meandering river migrate laterally, any channel will become the what? Any new channel can become the old channel or abandoned channel, and it becomes the new floodplain. The abandoned channel becomes the new floodplain, and on top of that, so there will be a deposit there before, right? So these are the deposits that were there before, these guys. So since it has now become the old channel, what will now happen on top of it? It has now become the old channel now, since it's migrating, it is migrating. So as it's migrating now, this guy has migrated, abi. So this guy will now become the new flood plain, the new flood plain. So since they come new floodplain, mud deposit will now be on top of the deposit, the sandbar that was here. So that's why at the top of a meandering facies depositional environment, we are going to have our mud, our floodplain on top of it, which consists of our mud or silt particles, fine grain setting majorly. Now, I'll just go over it again. When you are drawing your facies model, a standard facies model, you have to remember the kind of signs that represent the structures. This one that look like F that is falling down is the ripple. The T that has extra T on top is the planar, and this W or something that look like curve that cuts each other, that's known as the trough. So no matter you're drawing your particles reducing in size, you put these guys too in it. So that's talked about the meandering facies depositional environment or system. Now we'll need to briefly talk about a kind of system. We need to briefly talk about kind of system. We talked about the Crevasse Splay. Now, and the Crevasse Splay, in the Crevasse Splay is the kind of setting where normal we have our, like what I've discussed earlier, we have our, so it starts like this with the erosive base, the channel like deposit, trough, planar, ripple laminated sandstone. Okay, please write it in full in your exams. Ripple laminated sandstone, and this point, due to you're going to have fine grains here, which include your mud, on top of that's the normal setting. Your mud will be there. Mud has already ended, like what I just showed you earlier. So the mud, the floodplain, which consists of the plane, the main deposition is the mud or the clay or anyone. So they end the deposition environment. But due to the break in the overbank, what's going to happen on top of that mud? You have large grains or quartz grains deposited upon the mud. Large grains, maybe breccia or conglomerate deposited on top of the mud. Can you see? So like this, you have something like this. So this is how to draw for a crevasse splay. When a crevasse splay subdepositional environment is in the meandering depositional setting. So after that, no matter anything that is being deposited, it is still in a floodplain environment. You still have a floodplain closing at the end. So the meandering depositional starts with finely upward first, then move to what? Coarse, then later finely upward. Okay, finely, coarse, fine. Good. So that's how it works for Crevasse Splay depositional setting. We've come to the end of the meandering depositional environment. We've covered the Oxbow Lake subdepositional system. We've covered the Crevasse Splay subdepositional system, the Oxbow Lake, the Crevasse Splay. You know about the floodplain, about some little things. Now, just rounding up, we need to talk about the deposit that has been known. I mentioned earlier that the main deposit is point bars, and they consist of sandstone. You see things like trough cross-bedded, planar cross-bedded. Yes, like the rest. And they are good. Sandstone is a good reservoir for hydrocarbon, and they are not ephemeral. So this is a good difference between. So we are trying to differentiate or what contrast between braided bar deposits and point bar deposits. or the kind of deposits that happen between the meandering river and braided river system. So they're not ephemeral. Not ephemeral means temporary, something that is not lasting, that is not forever. So that is what happens. So the reason why the braided bar deposits is ephemeral, I explained it in the video, it's because it's fluctuates between high and moderate. So it keeps, so even the deposit that is there, when it's very high, erosion happens. You know, erosion is very, very more active in a very high energy regime. Okay, so now for this guy, it's very, very low energy regime, and what happens is that what it even migrates as the sediment begin to accrete. As sediment begins to accrete, lateral migration by avulsion begins to migrate. So the deposition is still there. It is not, nothing is obstructing it. Unlike in a braided setting where we have in between the channel, we have the deposit. Okay, we have the deposit. So we've come to the end of the video. Kindly like and subscribe to Tutors. Share with your friends, families. Thank you. The next video, we're going to talk about the lacustrine environment.